Hello students, how are you all? Hope everyone is fine and safe. Welcome to my channel and do subscribe and like the channel and press the bell icon so that you don't miss any of the topic from this topic, and we'll be surely completing the last part of the subject, and with this we'll be ending our trigonometry. Okay, so that is the last topic of trigonometry is trigonometric identities. Okay, in our syllabus we really have a very few trigonometric identities that is very easy to remember. Okay, what are basically identities? Identities are some of the things which holds good for any of the value, right? Like for example, a plus b the whole square is equals to a square plus b square plus 2ab. This is nothing but an identity, right? So trigonometric identities basically in our subject, I mean in our portion, it is just three. That's very simple. Sine square theta plus cos square theta is 1. Both put together, the squares of both the things will not exceed 1. Okay, the next identity which pertains to like sine and cos is over. What is left is tan, cot and secant and cosecant, right? So herein they are like establishing a relationship between tan and secant. We were having a relationship between tan and cot, right? We have a relationship between sine and cos, tan and cot, secant and cosecant. But herein, the sine and cos are together here. But here tan and secant relationship is shown. That is nothing but 1 plus tan square theta is equals to secant square theta. That is nothing but if we jumble these things to get the 1 at the end, what is the answer that we get? It is secant, keeping secant here, plus tan goes to that side and get minus tan, right? So secant square theta as it is, this minus this goes that side, plus goes that side of the equation and gets a minus tan square theta, which is equal to 1 remains 1. Okay, this is one of the identity. The same applies with the cot. 1 plus cot square theta is equals to cosecant square theta, right? So if you want to get in the terms of 1, what we do, it is cosecant square theta minus, since this plus goes to another side and gets minus, is equals to 1, right? So these are the basic identities. Okay, this and this. Okay, these three are the identities which we will be dealing in our topics now. Okay, all the problems deals with it. Herein it what it says that any value for the of any value of the theta, this holds good, this equation holds good, this LHS will be equal to RHS, right? So the things to remember is sine and cos. Sine square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, cosecant square theta minus cot square theta is 1. Okay, so these three things are very easy to remember. Now we'll quickly move on to the problems pertaining to this. Okay, evaluate the following. The first bit is 1 plus tan theta plus secant theta into the whole thing into plus 1 plus cot theta minus cosecant theta. Okay, in these problems, we directly can't apply the identity what we already know, right? There's something that feels like there's a missing thing. That is the squares are missing, right? And directly we just can't put up the squares because this is not equation to something, right? So that multiplying and dividing by this thing, squaring both the sides, or doing the same thing, we can't do that. So the best thing that we can do is applying the value of tan, secant, cot and cosecant. What is tan? What does we know? What is tan theta? It is sine theta by cos theta, right? This value we know. What is secant theta? 1 by cos theta, we know this also. Okay, and what is cosecant theta? It is 1 by sine theta. Based on these these formulas, we'll be substituting these values. It is very simple. 1, we are copying it as exactly 1, plus ka plus. Then tan theta is nothing but sine theta by cos theta, right? Then again secant is 1 by, what is secant? 1 by cos theta, right? So this thing we have just substituted the values again, the whole thing into 1 ka 1 we are copying, cot ka we are copying as, what is cot? It is ulta of tan. It is the reversal of tan, right? It is reversal. So cos theta divided by sine theta minus, what is cosecant? 1 by sine theta is the cosecant. Now it is the very simplest thing that we can do. We can just take out the LCMs of particular things, right? So what is the LCM or LCM here? It is cos, right? in this thing, it is cos theta is the LCM, right? Then herein, since we don't have anything, we'll be multiplying by cos theta, right? So cos theta, this is like cos theta plus, since it has already cos theta, we'll take up sin theta directly, since it doesn't require anything to be added, or I mean anything to be, you know, multiplied by in the denominator or something, numerator. So since it already has a cos, we'll copy this one as 1, right? One thing we have got it. Next thing that we will be doing is, what is the common like LCM of this? It is sin theta, right? Now we don't have anything here, sign here, so we'll be multiplying and dividing by sign here. So it will be sin theta, in place of 1 into sin theta will be sin theta. Cos theta will take as it is because already sin theta is present, and minus 1 will be taking as it is because it is divided by sin theta already, right? We got a simplified form. Now what we can do in this thing is, this doesn't seem like a formula. mm, like See, if you see cos theta plus sin theta plus 1, sin theta plus cos theta minus 1, what we can do, this sin theta and this cos theta seems as a, right? This is plus, this is minus, 1 is as b, right? You need to observe directly seeing the problem. You need to quickly see which identity it belongs. We know one of the formula, like a plus b into a minus b is equals to a square minus b square. This is the formula we are learning since a long since a childhood, maybe. Okay, so if we see this is fitting in, right? Cos theta plus sin theta in place of a, yeah, it is fitting in, right? And plus plus minus minus, we are taking b in place of b, and 1 is fitting, right? So what we can do, we can directly write in this terms, what is a square, what is our a square? Cos theta plus sin theta is a, right? So whole square, we have written this, minus, what is our b here? B is 1 square. Okay, we got this. Okay, since it's a multiplication between the two, this doesn't get an LCM, but it gets, multiplied. So cos theta into sin theta, right? Now it is very simple. Now see, we have a formula of the identity as sine square theta plus cos square theta is equals to 1 if it pertains to sine and cos, right? We have this thing, but we don't have any identity as such of this, right? So what are we doing? We are just simplifying the thing using our formula, right? What is a plus b whole square? Just now we just learned a square plus b square plus 2ab, right? But here, and you see, in place of a it's cos theta, in place of b it is sin theta. So cos square theta plus sin square theta plus 2 into sin theta into cos theta. Okay, this is a. Okay, this is a. This is, I mean, a square b square plus 2 into ab, right? Okay, anyhow, sin theta into cos theta. See, 2ab can be written as 2ba also, so not a big deal. We are just simplifying this whole value. Now still we are left with these values, so minus 1 square is 1. Okay, and the denominator as it is, cos theta into sin theta, right? Next, we can just put up the identity here. We can use the identity here. Cos square theta plus sin square theta is nothing but 1, right? We know from this identity, right? Okay, plus we will copy this as same, 2 sin theta into cos theta minus 1 divided by cos theta into sin theta. Okay, plus 1 and minus 1 gets cancelled, right? It's nothing but 0, right? But like 2 sin theta, let's see, 2 sin theta cos theta divided by, I mean, plus 0, nothing but 1 plus 1 and minus 1 gets 0, divided by cos theta into sin theta. Okay, now what happens? This sin theta gets cancelled since it's a multiplication. This cos theta gets cancelled. What are we left with? Its answer is 2. Now, the second bit is also same. We just need to simplify the things and use the formula of a plus b and all. You need to be very vigilant while using these, 4 marks problems. It will be pertaining to using the formula of a plus b the whole square thing and a square minus b square formula. That deals with that only, okay? So, sine theta plus cos theta the whole square plus sine theta minus cos theta the whole square. Herein, if you just check out, it's isn't it a formula like a plus b square and a minus b whole square, right? So what we are doing, first we will write the given values in every problem. Sine theta plus cos theta the whole square plus sine theta minus cos theta the whole square. It's simplifying that, right? So sine theta, like we are taking it as a plus b the whole square. What's the formula for a plus b the whole square? A square plus 2ab plus b square, right? Or you can interchange any of the values. Okay, a minus b the whole square, what is the formula for that? A square minus 2ab plus b square, right? So simply we are just using that formula here. No other thing we are doing, not a big deal. Okay, this is a and this is b. Imagine it is sine square theta plus 2 into sine theta into cos theta, right? 2ab. Okay, a b into b. Okay, plus cos square theta. Okay, it's just this value that we simplified. Still we have this value, be careful with the signs, it is plus, and now this value we are simplifying now. Sine square theta, since it's a minus, minus 2 into sine theta into cos theta plus cos square theta. Okay, this is a square minus 2ab minus b square, right? This is very simple that we just simplified it. Now there's nothing left in this problem except for the for the simplification. So we are doing sine squares and cos square in one place. Sine square theta plus cos square theta, okay, plus 2 sine theta cos theta. We are just rearranging this, nothing more. Again it is a plus sign in between, be careful. Sine square theta plus, see, sine square theta, we are rearranging it, sending cos in place of this thing, plus cos square theta minus 2 sine theta cos theta. Okay, now we know one thing, one of the identity, very famous identity, is nothing but sine square theta plus cos square theta is 1. This thing is 1, right? Sine square theta plus cos theta is cos square theta is 1. So we are replacing this value with using the identity. Sine square theta plus cos square theta is equals to 1. Okay, now we are replacing. That's it we have to do in the problem. This will be 1 plus 2 sine theta cos theta. See, this is not into, this is plus. Plus sine square theta plus cos square theta is 1 minus 2 sine theta and cos theta, right? So now here, since it's a plus, 1 plus 2 sine theta and cos theta plus 1, since it's a plus, minus 2 sine theta cos theta, right? We're just opening the brackets. See, 2 sine theta and plus 2 sine theta and minus 2 sine theta gets cancelled. It gets to be a 0, right? And 1 plus 1 is nothing but 2. We have simplified it. Quickly move on to the third bit. We'll move on to the third bit. That it says that secant square theta minus 1 into cosecant square theta minus 1. Right. So whenever we get this squaring type of things, you need to solve using the identity. Right. So we know one of the identity relating to secant. What is that? What identity it pertains? It is like 1 plus tan square theta is equals to secant square theta, right? Right. So like if we simplify, if we want to get like secant, secant value, we can directly replace here. Okay, what we can do, in exam you just remember any one simplified form. You don't need to remember each and every formula. Like 1 plus tan square theta is equal to secant square theta. It means that secant square theta minus tan square theta is 1, which we have already seen in the identity. Only one thing you remember in exam, the missing thing you need to substitute the things and get the answer. So what is secant square theta, it is 1 plus tan square theta. So we are substituting it here. So given, first we'll write the given value. It is secant square theta minus 1 into cosecant square theta minus 1. Also we know that 1 plus cot square theta is nothing but cosecant square theta, right? We will be using these both identities because it's pertaining to secant and cosecant. Okay, and it's a square also. So what is the secant in place of secant? 1 plus tan, right? We are replacing secant with 1 plus tan square theta, right? And minus 1 is 1. Okay, we are done with it. Now we are dealing with it, this one now. So what is cosecant square theta? What is cosecant value? 1 plus cot square theta. 1 plus cot square theta, right? Minus ka minus 1, right? We have just simplified. Now it is very simple. 1 plus, we are just removing the brackets, okay? 1 plus tan square theta minus 1, okay? 1 plus cot square theta minus 1. See, plus 1 and minus 1 get 0, right? What are we left with? Tan square theta into cot square theta, right? So, and one more thing that we know regarding these relationship is that cot is nothing but the inverse of tan square theta into 1 by inverse of tan, right? Cot is inverse of tan square theta. So tan square theta gets cancelled. I mean, since it's a multiplication, answer will be 1. And simplified. Okay, so we'll move on to the next question, that is show that cosecant theta minus cot theta the whole square is equals to 1 minus cos theta divided by 1 plus cos theta. It is, we have to prove that. So it is LHS and let us take this as RHS. Okay, first let us consider the LHS, copy the given aspect minus cot theta the whole square. Since the cosecant and cot does have a relationship, but what we have in our the final answer that we need to get in which terms, it is in cos terms, right? So what are we doing? We are changing these things to the cos and sine terms, right? So what will be the cosecant theta? We know that cosecant theta is nothing but 1 by sine theta, right? This is the formula. And what is cot theta? It is nothing but cos theta by sine theta. Okay, we are just copying this and the whole square. We know that, I'm writing the formulas here. We know that cosecant theta is 1 by sine theta, right? And what is tan theta? We know sine theta by cos theta, right? So what will be cot theta? Inverse of tan cos theta by sine theta. That's what I'm just substituting the value of cot here and value of cosecant as 1 by sine here. That's it I'm doing. Now you need to just simplify the thing. Okay, so what is that? Here in the sign is minus, it's not into. So what we will be doing, the LCM is common here, sine theta, okay, and 1 minus cos theta, right, the whole square. Now what we will be doing, distributing the squares here, okay, 1 by cos theta the whole square in the numerator and giving the square to the denominator also. Okay, the identity which we are familiar with regarding the sine square theta is sine square theta plus cos square theta is equals to 1. What we will be doing, since we need to get in the cos term, what we will be doing, sine square theta, we will keep the sine square theta as it is. We want to know sine square theta. So 1 as it is, and cos square, since it's a plus cos square, we are sending that cos to the other side. It will become minus cos square theta, right? So what we are doing, we are keeping the numerator as it is. What we are substituting denominator with this formula, 1 minus cos square theta, right? Did we get that? Okay. Sorry. Yeah. Now herein what we can do, either we can expand this as like a plus a minus b the whole square, or simply what you can do, since depending on the denominator we will act for the numerator. Okay, 1 minus cos theta the whole square divided by 1 minus cos square theta. See, we are familiar with one of the formula that a square minus b square is equals to a plus b. into a minus b, right? So we will be applying the same formula here. This is this as a, this as b. Okay, nothing is given for the 1. It means that 1 square is 1, 1 cube is 1, right? So there's no problem to add a square here. Okay, so what we are doing, that a square minus b square formula we are applying here. What is a here? 1. Okay, what is b here? Cos theta. Okay, what is a here? 1. What is b here? Sorry, minus cos theta. We are simply using this a square minus b square formula here and expanding it. Okay, the next thing, the very next thing is that what we will do here, we will not expand the formula here, like a square plus b square plus minus 2ab and all, but what we will do, 1 minus cos theta square is nothing but these aspects into this thing 1 minus cos theta into 1 minus cos theta, the same thing. Okay, the duplication of it, the same thing. This whole things will be equal to square. Okay, divided by 1 plus cos theta into 1 minus cos theta, right? So what we will do, 1 minus cos theta, 1 minus cos theta cancel. What is left over is 1 minus cos theta. This 1 minus cos theta is left over, and 1 plus cos theta is left over. So isn't it RHS? Isn't it RHS? Yes, we proved. Hence proved. Hopefully we'll be completing our trigonometric chapter in like next video probably, and till then take care, bye bye, have a nice day.